Now we have to discuss about the types of energy band in atom and also how these types of energy band is working for the elements, suppose conductor, semiconductor or insulator. So first of all, the first energy band types is valence band, second one is conduction band, and third one is forbidden band. And we have to write it as in short term, which is VB, second one is CB, and third one is FB. So first of all, which is valence band. As far we know, there is an atom and the outer shell of the atom has some electron, and each of the electrons energy level or the storage amount of energy is not same. So there are various types of electron inside the atom and also outer shell of the atom, and this outer shell atom's electron has no similar energy level. So these types of energy level is called energy band. And here in the atom, as there are several types of electron stay at the outer shell of the atom, there are three types of energy band is working among those electron. So the first one is valence band. What is actually the valence band? So when if you see this, there is a outer shell of the atom and there are several types of electron outer shell of the atom. Suppose there are five electrons, and between this among these five electrons, some electrons have a higher energy to go from one atom to another atom, and some electron has a lower amount of energy, and those electrons cannot go from one atom to another atom because they have lower energy. Suppose there are five electrons A, B, C, D, and E, and those five electrons are stay at the outer shell of the atom. And suppose A, B are two electrons, these have no enough energy to go from one atom to another atom. So these two types of electrons have a lower amount of energy, and this energy level is called valence band. So the electron whose have the energy level into the valence band, they cannot go from one atom to another atom, they just stay the outer shell of the atom. And center is our nucleus. Okay, right. The second one is our conduction band. So the conduction band is actually another types of energy shell or energy levels, and when the electrons are going to this energy shell or achieve the energy as the conduction band energy level, then this electron can easily pass from one atom to the another atom and also working as a free electron. So suppose our between among these electrons C, D, and E, the rest of the three electrons have a good energy, have a higher energy, than they can go from one atom to another atom because they have a higher energy, and this higher energy is actually stored by this electron, and this energy level or energy shell is called conduction band. So the electron which is into the conduction band level energy, or the electrons which have a higher energy or conduction band level energy of the electron, and this electron can easily pass from one atom to another atom. So when we see or when we talk about the conductor have a good chance to flow electron through its surface or among itself. So this conductor have a higher amount of conduction band level energy electron. So the last one is our forbidden band. So the forbidden band is actually there is a difference between the two band, which is valence band and the conduction band, and there is a gap between the two band because the electron which are A and B, which have a very lowest amount of energy, cannot go from one atom to another atom and also stay the outer shell of the atom. And this atom's band is a valence band, we have said this. But the conduction band is also the another types of higher energy level band that can achieve the that can gives the electron the way to go from one atom to the another atom. So there are two stages or there are two levels, and between these two levels there are another energy band that is called forbidden band. So actually you can see there are three types of figures, and I have to discuss about these three types of figures that indicate us how these three types of band is working on material, suppose conductor, semiconductor, or insulator. So in the forbidden band there is no electron, because no electron achieve the energy of forbidden band. The all the electrons, the outer shell of the atom is all the electrons of the outer shell of the atom are trying to achieve valence band energy level or conduction band energy level. But the forbidden band is actually an idea that no electron can achieve these types of energy level energy. So there are another important thing that the valence band, conduction band, and forbidden band, those are not any place, those are not any address, those are only the indication of the quantity of energy level. So the valence band energy level is lower, conduction band energy level is higher. If the electron achieve the lower energy, then it cannot go from one atom to another atom, it can stay at the outer shell of the atom, and those electron level or those electrons energy level is called valence band. Not we can say that the energy the electron is are in valence band position. There is no position, because those are the levels, not address or not places. Okay, so there are three types of figure. The first figure that indicate valence band is at lower condition, conduction band is at higher condition. And here we can see there are some electrons in the valence band, there are also some electrons in conduction band, but these electrons have a highest amount of energy, and this energy helps the electron to pass from one atom to another atom. But inside this valence band there are some electron 1 2 3 4 5 6, and those 6 electrons cannot go from one atom to another atom because their energy level is so low. And I have to indicate the energy stays as y-axis. Suppose this is the y-axis and this is our x-axis. So as y-axis indicates the energy, so we can say that there is no place between there. This is only the energy level or energy range. So the valence band has the lowest energy range or energy level because it is situated at the lower level, but the conduction band is situated at the higher level. So there is a big gap between the valence band and the conduction band. The electron of the valence band are trying to achieve the conduction band level energy, but when the electron achieve those types of electron achieving the conduction band level energy, then this electron can easily freely move to one atom from one atom to another atom. But there is no chance because the gap is very high, and the electron of the valence band cannot go from valence band to the conduction band. So in that cases we can say that this condition is only applicable for insulator, because we know in the insulator there is no chance to flow the electron inside in it, or the no electron can flow through the insulator. So this condition is called our insulator. So in insulator you can say that the valence band electron and the conduction band electron gap are too high gap is too high, and the 6 electron volt is required to the electron which is inside the valence band. So if we apply 6 electron volt energy to the electron which is inside the valence band, then this electron can easily going from valence band to the conduction band. But here you can say 1 electron volt is 1.6 into 10 inverse 19 joule. So joule is the unit of energy, as well as electron volt is the unit of the energy. So there is a high amount of energy, 6 electron volt is required to that electron to go from valence band to conduction band. But we cannot apply or we cannot give 6 electron volt energy to the electron which is situated at the valence band, there is no chance to the electron which is going from valence band to the conduction band of insulator. That's why the insulator cannot flow the electron. Our next thing is, okay, another thing that I want to share, that is there is a bond gap, and the bond gap is actually nothing, it is the forbidden band energy level. So the forbidden band energy level is working between valence band and the conduction band. So between this energy level band, one gap is working, and this is called bond gap, and also this is called forbidden band. And the energy of the forbidden gap or forbidden band is denoted by E naught. So here 6 electron volt is actually nothing but this is the value of E naught. So for insulator, the forbidden band gap or energy level is so high, which is 6 electron volt. Our next one is semiconductor. You can see there their valence band is again the same position as before. There is a x-axis, and this is our y-axis, and y-axis is denoted by the energy. But the conduction band and the valence band, they are each other very much near, because you can see there is a big gap but there is a small gap. So this small gap is indicates the forbidden band or band gap of band gap between the two band is too much low, which is 1 electron volt. So 1 electron volt is very lowest amount of energy, and we can apply this 1 electron volt energy to the electron which is situated at valence band, and this electron can easily going to the conduction band. So if we apply some heat energy, suppose there is a candle or heat source, so if we apply some heat, then this heat energy is applicable to the electron, and this heat energy can be is stored by the electron which is situated in valence band, and this electron can easily get the 1 electron volt from heat or pressure, and then this is going from valence band to the conduction band. And when those types of electron are going to the valence band to the conduction band, then they can easily move from one atom to another atom and also working as a free electron. So in that case, thus we can say this material is going to be a conductor. So in semiconductor, if we apply heat, then the valence band electron can easily get the energy, and this energy can help the electron to flow from one atom to the another atom. So this is our semiconductor condition. And in this semiconductor, the forbidden gap is very much low, which is all about 1 electron volt. And the last one is our conductor. And in this conductor, you can see there is a two energy band, valence band and the conduction band, and between these two band there is no forbidden band. As there is no forbidden band, so there is no chance to obstacle the valence band electron for to flow, because this valence band electron can easily pass from valence band to the conduction band, and when this electron going to the conduction band, then it can get the chance to flow very much speedily. So we can say that there is no forbidden gap in conductor, and also the electron which is situated in the valence band can easily flowing, because the valence band and the conduction band has attached to each other, and also they can easily get the electron, they can easily flow the electron, which is very much applicable for conductor. So in this conductor, you can see there is a no forbidden gap. So we do not apply any heat, we do not apply any pressure to flow the electron through the conductor, and conductor has a very much very high amount of free electron which have a very high amount of energy which can help them to flow from one atom to the another atom. So one thing that I want to share, in that semiconductor there is 1 electron volt is our forbidden band amount. So for silicon, we can say that there is a silicon and also there is a germanium, and silicon and germanium are the very good semiconductor material which we have to use in our electronics device. Okay, so for silicon semiconductor, the amount of forbidden gap is 1.16 electron volt. So this is 1.16 electron volt. And for the germanium, which is another famous semiconductor, the forbidden gap between the valence band and the conduction band is 0.75 electron volt. So this is actually the value of the forbidden gap energy level. But why the value are not same? As the two types of semiconductor are same material like semiconductor, but why silicon's forbidden band energy level is 1.16 and why germanium's energy forbidden band's energy level is 0.75 electron volt? This is the very important question for you, but I want to answer this question because we can see if we consider the silicon has a small shape, but if we consider the germanium has a good big shape because big size. Okay, so silicon has a small size because it has the lower amount of orbits, but for germanium it has a big size because it has a higher amount of orbit. So when the silicon's last orbit contains some electrons, suppose 4 electrons, because we say we know about the silicon, it has 4 electron outer shell of the atom, and this 4 electron can easily attracted by the nucleus of the silicon, and the distance between the nucleus and the outer shell of the orbit is very close, so the electrons of the outer shell can easily attracted by the nucleus in a very big amount. So in that time, if we want to replace the electron from the outer shell of the semiconductor silicon, then there is we need the high amount of energy. So in that cases, if we want to convert, if we want to pass the electron from valence band to the conduction band for a silicon, then this is this is so much tough because the electron is highly attracted or attached by the nucleus. But the next thing is our germanium. As the nucleus of the germanium is distance is a high amount of distance from the outer shell of the germanium, then there is no chance to get this electron, to catch this electron or pick this electron from one atom to the another atom. So in that case, there is the lower amount of attraction between the nucleus and the outer shell electron of the germanium, and for this reason there is it takes the lower amount of forbidden band energy, which is 0.75 electron volt. So in this type, only the difference between the shape or between the size, this is actually the main thing why the value of forbidden band of silicon and germanium is different, and this is only the reason of their size. The silicon is higher size, and silicon is a small size, but germanium has a big size. So this is the all about our energy band in the atom. And also we have another information, as we indicate the forbidden band energy level as E naught. So E naught is 6 electron volt for insulator, E naught is approximately 1 electron volt for semiconductor, but E naught is for conductor is 0 because there is no forbidden band between the valence band and conduction band of a conductor. So this is all about our types of energy band and how it works on the three types of material. So finally, I want to share another good thing, that is the people who are watching this video, please share and also support our videos, and also like our videos, subscribe our YouTube channel. And you people can easily hashtag crash school, and you can share this hashtag and also upload this hashtag on your social media like Facebook, Instagram, Twitter, so that I can easily find out how much people will use this hashtag. And also you can visit our official website, which is thecrashschool.com. Here you will find the various types of educational material which is about electrical and electronic engineering, and which is totally free. So please share our videos, subscribe our channel, use this hashtag crash school and upload it on your social media, and also visit our official website, which is thecrashschool.com.